So this is the first video in chapter 14, which is frequency response. This is an extremely important concept in several different classes you will have, from signal processing to controls. And the transfer function will also be important. And in 285, we did talk a little bit about the gain in a circuit. So in 285, in particular in chapter 5, op amps, we talked about, I'll give you a circuit and say, what is V out over Vn in a circuit like this? And this is the negative input. So in this case, we only said V out over Vn is the gain. And now we're doing transfer functions as a generalization of this idea. So we're going to see our circuits as linear and time invariant, and the circuit has a certain transfer function, and I'm putting it an input, for example, a V in, and out comes V out. I'm going to call this the voltage gain, but now it's going to be frequency dependent. So the transfer function is more general than this, what we had seen in 285, because now, actually it's going to be a graph, but h of omega will be V out, and we're talking here phasors over Vn, and I can call this also voltage gain. But it's really the plot will include magnitude and phase. So if I'm talking about phasors, of course I have those two. It will be in the end really two plots. Instead of voltage, I could have also done current. And so I have a second option here, a second flavor of transfer function. That's a current gain, which is also this same idea, IO over I. I gain I was going to write, but how about current gain? And now the other two options are related to impedance. So the transfer impedance, we're going to define as another kind of a transfer function, also h of omega, which will be VO of omega over the input current. In general, you can also define the opposite of this, which is a transfer admittance, even though I rarely see this asked for in circuits. Which is the output current divided by the input voltage. So this is exactly what the book actually is giving, and this is a block diagram. A lot of times this is called the plant, so in control systems it's also input output in plant instead of transfer function. Here we're going to call this the forcing function, and this is the forced function. So this is the 14.2, and the next part of this same section is solving circuits, which is much more fun. So let's do this in the next video.